Right, question number 2, Roman 1. You have been asked to list all the elements of the sets, the universal set P and set Q. Right, question 2, Roman 1. What should be the elements of the universal set? The whole numbers between 8 and 17, that's 9, 10, 11, 12, 13, 14, 15 and 16. And set P multiples of 4, that is 8, or rather 8 doesn't come. From the universal set we pick 12, that's a multiple of 4. And what's the other multiple of 4 that is there in the universal set? 16. Then comes set Q, square numbers. So let's pick the square numbers from the universal set. That's 9 and 16. 3 times 3 is 9 and 4 times 4 is 16. Roman 2, represent these sets in a Venn diagram. So what's the Venn diagram? We first got to put a boundary like this. First the universe to be made. So we make the universe, this is the universe. So inside that we have a set called P. Since P and Q has common elements, 16 is a common element, so P and Q should be intersecting like this. What are the, first you got to write the common elements of P and Q. That is 6, there's only one, that is 16, so it has to come in the middle. So 16 is done. Now set P, it's 12 here. Set Q has 9 here. What would you do for the rest of the elements that is there in the universal set? It has to be written outside the circles. 9 is already written inside the circle. 10 got to come here. 11, 12 is already written inside a circle. 13, 14, 15, 16 is already written inside a circle, so it won't come out. Right, let's look at Roman 3 now. You have been asked to write the elements of the set P complement. P complement or complement of P. What does complement of P mean? Out of what is there in the universal, out of what is there in the universal set, what is not there in P, or the elements which are not there in P should come to the complement of P. So it's quite easy to see, it's quite easy to do this question if you look at the Venn diagram. So what are the elements that's outside P? So let me draw the perimeter of set P in orange. So what are the elements that's outside this orange circle? Those are the things which should come to the set of P complement. So those are, what are the items? 9, 10, 11, 13, 14 and 15. Right, that's part A of Roman 3. What's part B? You have been asked to do P intersection Q complement. So first, so let's do this here. Question B. To keep it for the set, to make my explanation easy, let me write the set P first. What is set P, which we already know, that is 12, 16. And we'll also write the set Q complement. Q complement. What does Q complement mean? The elements which are not in set Q. It's quite easy to figure out the elements which are not in set Q by looking at the Venn diagram. So set Q, let me highlight in orange, or rather red. So what are the items, that is, what are the items or the elements that are outside this red circle? those are the ones which should come to the set of Q complement, the elements which are outside the circle of Q. So what are those? That is 10, 11, 12, 13, 14, 15. So all the elements except for 16 and 9 should come to the set of Q complement. Why don't 16 and 9 come to Q complement? Because 16 and 9 are inside the circle Q. Now, when we write Q complement, what do we write? The things which are outside the Q circle. Things which are out of the Q circle. Right. So now we are in a position to write what is P intersection Q complement is. So let's write what is P intersection Q complement. What does that mean? What does intersection mean? Common elements. Elements common to, or the items that you see in both the sets P and Q complement. P is here, Q complement is here. Compare the two sets. Compare the set P with set Q complement and take out the common elements. What about 12? Does 12 come in both the sets? Yeah, 12 is there in set P and 12 is also there in set Q complement, which means it's a common element. So P intersection Q complement, 12 would come because it's a common item. Intersection means common elements. What's the other item you see in set P? 16. Does 16 appear in the set of Q complement? Where is Q complement? Right below P, we have written the set of Q complement. What I'm circling now? In this Q complement set, do you see 16? No, it is not a common element. So there is only one element which is common to both the sets P and Q complement, that is 12. So there's only one element that's going to come for this set. P intersection Q complement is equal to a set with one element. What is that element? 12. Right, let's look at question C now. P intersection Q, quite easy. What is P intersection Q? The items which are common to the set of P and Q. You can simply get that by looking at the diagram. So the items common to the set P and Q are going to be at the place where the two circles intersect. How many elements do you see at the place where the two circles intersect? There's only one element, which is 16. So what is P intersection Q here? 16. Once again, we are getting a set with only one element. So P intersection Q is 16. But remember, this is just a coincidence. In both the questions, question B and C, both of them were intersection questions. So in both of those cases, we got sets with one element as the answer. But that is not a general case, okay? That's just a coincidence here. But in your exam questions, sometimes the intersection set will have multiple elements. There is no rule saying it should have only one element, right? But in this past paper that we are discussing, for the intersection questions, we got sets with one element, but that's just a coincidence, all right?